All right, so this next part we have a bunch of rules here, and I've typed in a lot of the rules. I left number 4 blank, but just to look at a few of the rules first. This first one right here is just telling you the derivative of something added. You just do the derivative of each part added. So, I mean, you already know that kind of stuff. You guys know that there's a constant inside and you're trying to do the derivative. That constant can just be pulled out, and then you do the derivative of the item. So these are supposed to be space curves and things like that, but just so you know, all the same rules still apply. So this one right here, this is when you have a function, and then you have your space curve right there. And so it just looks like your general product rule. You do the derivative of one part times the original other part, and then you do the derivative of the part that you didn't do before times the original other part. So of course, addition, you can do those any way you want. They're commutative, so you can do it either way. So let's look at number 4. So number 4 would be called the dot product rule because you're doing the derivative of a dot product right here. So it's pretty much just like the quotient rule, except when you are like the product rule. So except though instead of multiplying the things, you do their dot product. So you would do like, u prime of t dotted with v of t plus, then you would do v prime of t dotted with original u of t. And of course, since you guys all like to do it backwards, you could do it backwards too, because the addition wouldn't make a difference. So then number 5, you have the cross products, just kind of a similar thing there. But make sure that you would do it in the order that it states here, because remember, a cross product, if you do it the opposite way, like if these two things were switched, then it would come out negative, so you want to do it in the way that it's written. And the last one's a chain rule. So of course you do the derivative of the whole thing times the derivative of what's inside, right? So we're just going to do a couple of these on the next page. And oops. All right, so here we go. So this is the derivative of v of t squared. So before we start this, it would be a good idea to do this. A lot of these, I'm going to need the derivative of my u and my v up here. So I'm just going to do the derivative of those right away so that I have them there waiting for me. So u prime of t, I would get basically 1i over here plus 2t with my j minus 3t squared with the k. Okay. And over here for v prime of t, I'm going to put up top. I would have the derivative of sine as cosine, so I have cosine of t with the I. The derivative of cosine is negative sine, so I have negative 2 sine t of j, and then cosine negative sine, so negative sine t of k. So if you have those things waiting for you there, then it makes everything a lot easier. So this guy right there. So this is like a chain rule. So I have basically to do the derivative with t squared put in, and then times the derivative of t squared, which is 2t. So since I already have my derivative of v right up here, this is going to be a little bit easier. So I'm just going to take and multiply 2t times the derivative vector and of v, and all along as I do this, I'm going to be putting t squared in place of t. So my derivative of vt, first I have my cosine. So I have cosine of t squared. Remember, I'm plugging t squared in. And then I'm writing this in component form. So then I have negative 2 sine, but it's of t squared now. And finally, the last one is negative sine, but it's of t squared now. So of course, if you wanted to multiply the 2t through, you could. So you'd say you have 2t cosine of t squared. And then you'd have negative 4t sine of t squared, and then negative 2t. Oopsie. Sine of t squared. So also realize here that your answer is just a whole nother vector. So, all right. So for this one, this letter B here is an example of, let's see, this guy right here, where you have a function times a vector, right? So however you like to do it, it's kind of like product rule in a way. We're splitting it right here. So it doesn't really matter which order you do it. So I guess I could do the derivative of the v part first. So let's go for it. Let's see. So let's see. I have t squared is going to stay. That's going to multiply by the derivative of v. So that would be, well, like I have up top here, cosine t, negative 2 sine t, negative sine t, plus, then I have the derivative of t squared, which is 2t, times the original v vector. So I have sine of t as my original v vector, and then 2 cosine t, and then cosine t. So the annoying part is now I have to add these together. And so it's just going to be this really long, humongous, annoying answer. So realize that when I do this, I have t squared times cosine of t added with 2t times sine of t. So that's what I'm doing each time. So my one big answer is t squared cosine of t plus 2t sine t. That's the x part, or the I part. Then I have negative 2t squared sine of t plus 4t cosine of t. I'm getting that from this and this. All right. Then I have negative t squared sine of t plus 2t cosine of t. Let's take a look, make sure that seems right. Yep, all good. All right, so finally the last one, letter C. This is the dot product rule. So with this one right here, I have to, now you could also dot them to begin with and then do the derivative of that. But oftentimes, you know, it'd be kind of gross to dot them to begin with, but here we go. So I'm going to do u prime of t dotted with v of t plus, then I'm going to do u of t dotted with v prime of t. So you could switch the order if you want, but I'm just going to do them this way. All right, so u prime of t. So u prime of t, I already have that right here. It's 1, 2t. So that's 1, 2t, and negative 3t squared. I'm dotting that with v of t, the original v of t. So that was sine, 2 cosine, and cosine. All right. Plus, now I keep u of t. So now I keep the original t squared, and negative t to the third. And I dot it with v prime of t. So v prime of t was up above. That was cosine, negative 2 sine, and negative sine. So I'm going to pause the video and kind of write the next couple steps so you can unpause it after or you can pause it too to kind of copy them down in a second. All right, so just like with any dot product, you don't get another vector, you just get a scalar, like another answer. So if you knew what t was, you would plug t in here and just get your answer. So I dotted those things, and when I look at this answer, there is nothing that's similar except for one part. Let me just check it over. Yep, one part. I got this 4t cosine t, and over here I have another t cosine t. So I have 5 of those. So basically, if you wanted to rewrite it, you would put those together and put 5t cosine t. All right, and that is that. So let's go to this last page here. So of course, all these things, just like you saw, we did limits before, we did derivatives, and so you can also do integrals. So basically, if you want to do the integral of a vector or a space curve, you would have to do the integral of the function f of t, because that's what the x part was, and then of course d of t is here, and then from a to b if you were given that, just like you were here. And then the middle one is usually called g, so you do the integral of that part, and then from a to b. And the last one was called h, so we do the integral from a to b of h of t dt. Right. All right, and then of course you can put plus c on there too if there's no boundaries. So that's what this piece is saying, that if you do have boundaries, then you subtract the 2 plugged in. All right, so we are going to do this last one. We're trying to do the integral from 0 to pi over 2 of r of t, which is right here. So basically I have to just do each one. I have to do the integral of 2 cosine t dt. I have to go from 0 to pi over 2. Okay, so integral of cosine would be sine. So I have 2 sine t I have to plug in 0 and pi over 2. All right, so sine of pi over 2 is 1, and sine of 0 is 0. So I get, basically I get 2 minus 0, so I get 2 from that part. Okay, and then I have to do the center, so the integral of sine. So the integral of sine of t dt from 0 to pi over 2. The integral of sine is negative cosine, so I get negative cosine from 0 to pi over 2. So the cosine of pi over 2 is 0, so I get negative with the 0 minus the cosine at 0 is 1, so I get this negative again, negative 1. So basically you get just 1. Okay, so there's that part. And for the last piece, I have the integral of 2t. So I have the integral from 0 to pi over 2 of 2t dt. So the integral of 2t would be 2t squared over 2, so it would just be t squared from 0 to pi over 2. So plugging in 0 doesn't do anything for me, but plugging in pi over 2, I would get pi squared over 4. So there are my three parts. I have my integral here would be another vector. It would be 2, 1, and pi squared over 4. Now, if you have the option with this one that I just did, you could also go ahead and find each integral, just like in your mind. So you have, this is one integral, this is another, and then this is the third one. And so what you could do, instead of writing it the way that I just did it, like as 3 separate problems, you could actually say that your integral is 2 sine t, comma, negative cosine t, comma, t squared, and then put your little bars here and say that you're going to evaluate it from 0 to pi over 2. So that way, when you plug in pi over 2, you get your 2, you get 0, and you get pi squared over 4 when you plug in pi over 2 to all those things, and then minus when you plug in 0. So you plug in 0, you get 0. Then you plug in 0, you get negative 1. And then you plug in 0 to the last part, t squared, and you get 0. And of course, the subtraction of these two vectors would produce the same answer that you got right here. So it's just an alternate way of writing it, like however you like to do it. All right, and so I guess for homework, since I took 12 minutes here, why don't you cut it like right there and do those 5 problems. And then we'll work on the rest in class. Bye-bye.